NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve a fractional part equation step by step, following a simple algorithm. Here is our example. We will read it as the fractional part of x plus 1/3 equals 1/2. Step 1. Recall the rule for the fractional part. If the fractional part of capital X equals P, then capital X equals P plus K, where K is any integer and P is between 0 inclusive and 1 exclusive. Now apply that rule to x plus 1/3. That gives us x plus 1/3 equals 1/2 plus K, where K is an integer. Step 2. Isolate the variable x by subtracting 1/3 from both sides. Step 3. Use a common denominator to combine the fractions. 1/2 minus 1/3 equals 3/6 minus 2/6. That simplifies to 1/6. Therefore, x equals 1/6 plus K, where K is any integer. For intuition, let us mark all solutions on a number line. They repeat every 1 unit, shifted by 1/6. We will plot a few values from -2 to 3. We will multiply both sides by 8 to clear the fractions. Step 1. Clear fractions. Multiply every term by 8. This becomes 8 times curly brace x curly brace squared minus 6 times curly brace x curly brace plus 1 equals 0. Step 2. Substitution. Let y equal the fractional part of x. Remember, a fractional part is always between 0 and 1, including 0 but excluding 1. So we solve the quadratic in y, where 0 is less than or equal to y, and y is less than 1. Step 3. Factor the quadratic. 8y squared minus 6y plus 1 factors as open parenthesis 4, y minus 1 close parenthesis times open parenthesis 2, y minus 1 close parenthesis equals 0. Setting each factor equal to 0 gives y equals 1/4, or y equals 1/2. Both values satisfy the condition that y is between 0 and 1. Step 4. Back substitute to find x. If the fractional part of x is 1/2, then x equals 1/2 plus K, where K is any integer. If the fractional part of x is 1/4, then x equals 1/4 plus K, where K is any integer. This shows the solutions are periodic, with period 1 along the number line. Therefore, the complete solution set is all x of the form 1/4 plus K, or 1/2 plus K, for any integer K. Example. We will solve a fractional part equation step by step, making each algebra move clear and visual. Step 1. Use the definition of the fractional part. If the fractional part of u equals a, then u equals a plus K, where K is any integer. We apply that to the expression 3x minus 1/4 equals 2/3 inside the braces. So 3x minus 1/4 equals 2/3 plus K, with K an integer. Step 2. Isolate the term with x. Add 1/4 to both sides. That gives 3x equals 2/3 plus 1/4 plus K. Step 3. Combine the fractions 2/3 and 1/4. Use a common denominator of 12. 2/3 is 8/12, and 1/4 is 3/12. So that sum is 11/12. Therefore, 3x equals 11/12 plus K. Step 4. Solve for x by dividing both sides by 3. We get x equals 11 over 36 plus K over 3. This is the full solution set for any integer K. Let's read the problem. We need to solve the equation. The fractional part of 2x plus 2/5 equals 1 and 1/3. Step 1. Convert the mixed number on the right side to an improper fraction. 1 and 1/3 equals 4/3. So our equation becomes the fractional part of 2x plus 2/5 equals 4/3. Step 2. Recall the definition of the fractional part. For any real number y, the fractional part of y is always greater than or equal to 0 and strictly less than 1. Let's visualize that on a number line by highlighting the interval from 0 to 1, including 0 and excluding 1. Step 3. Now, let's check the right-hand side. 4/3 is approximately 1.33, which lies to the right of 1. That means the equation is asking a fractional part, which must be less than 1, to equal a number greater than 1. This is impossible. Therefore, there is no real value of x that satisfies the equation. The equation has no solution. In this lesson, we will solve the equation 25 to the power of the fractional part of x equals 5. We'll follow a clean 4-step algorithm and finish with an intuitive number line picture of all solutions. Step 1. Write both sides with the same base. Since 25 is 5 squared, we rewrite the left side using base 5. This gives 5 to the power of 2 times the fractional part of x equals 5 to the power of 1. Step 2. Equate the exponents. When positive bases are equal and not 1, the exponents must match. So 2 times the fractional part of x equals 1. Step 3. Isolate the fractional part. Divide both sides by 2 to get the fractional part of x equals 1/2. Step 4. Express all x that have a fractional part of 1/2. By definition, the fractional part of x equals x minus the floor of x. So x equals the floor of x plus the fractional part of x. Since the floor of x is any integer, call it k, we get x equals 1/2 plus k, where k is an integer. To make this solution feel intuitive, let us picture the number line and highlight all solutions. Every solution sits exactly halfway between consecutive integers. That means dots at -2.5, -1.5, -0.5, +0.5, 1.5, 2.5, and so on. Let us verify one value quickly. If x equals 1/2, the fractional part is 1/2. So the left side becomes 25 to the 1/2, which equals 5. That matches the right side, so it checks out. Final result x equals 1/2 plus k, where k is any integer. Welcome! In this lesson, we will solve the equation 10 to the power of the fractional part of x equals 0.8. Our question is, does any real number x satisfy this equation? Step 1. Recall the definition and range of the fractional part. The fractional part of x, read as curly brace x curly brace, is always between 0 and 1, including 0 and excluding 1. Let's visualize the interval from 0 to 1, closed at 0, and open at 1. Step 2. Since the base 10 is greater than 1, the function 10 to the power t is strictly increasing. Therefore, as the fractional part moves from 0 up to 1, 10 to the power of the fractional part will move from 1 up to 10. Let's graph y equals 10 to the t from t equals 0 to t equals 1 to see this. Step 3. Compare with the given value 0.8. Draw a horizontal line at y equals 0.8. Notice that this lies below 1, but 10 to the power of the fractional part must be between 1 and 10. Therefore, there is no real x whose fractional part makes the expression equal to 0.8. To summarize, the fractional part of x lies from 0 to 1. Because 10 to the power t is increasing when the base is greater than 1, the value of 10 to the power of the fractional part must be between 1 and 10. Since 0.8 is less than 1, the equation has no solution. In this lesson, we will solve an exponential equation that involves the fractional part function. Our equation is 4 to the power of fractional part of x plus 4 to the power of fractional part of x plus 3 equals 4. Recall, the fractional part of x, written as left brace x right brace, is the amount after removing the integer part, and it always lies between 0 inclusive and 1 exclusive. A key property is that adding any integer inside the braces does not change the fractional part. Left brace n plus p, right brace equals left brace p, right brace, for any integer n. Since 3 is an integer, we immediately have left brace x plus 3, right brace equals left brace x, right brace. Let's visualize why this is true on a number line, and then apply it to simplify the equation. Using the property, the equation becomes 4 to the power of fractional part of x plus 4 to the power of fractional part of x equals 4. That is 2 times 4 to the fractional part of x equals 4. Dividing both sides by 2 gives 4 to the fractional part of x equals 2. Rewrite 4 as 2 squared. Then we have 2 raised to 2 times fractional part of x equals 2 to the first power. Because the bases are the same and positive and not equal to 1, the exponents must be equal. That gives 2 times fractional part of x equals 1. So the fractional part of x equals 1/2. Any real number x can be written as an integer k plus its fractional part. Since the fractional part is 1/2, the complete solution is x equals 1/2 plus k, where k is any integer. As a quick check, take x equals 0.5. Then the fractional part is 0.5. The left side is 4 to the 0.5 plus 4 to the 0.5, which is 2 plus 2 equals 4. The same works for 1.5, 2.5, and so on. 4. The same works for 1.5, 2.5, and so on. Therefore, the solution set is all real numbers congruent to 1/2 modulo 1. In other words, x equals 1/2 plus k for any integer k. Well done! In this lesson, we will solve an equation that involves the fractional part of a number. The fractional part of x, written as curly brace x curly brace, is defined as x minus floor of x, and it always lies between 0 inclusive and 1 exclusive. Our goal is to solve the equation shown step by step with clear reasoning and visuals. Step 1. We simplify using exponents. 125 is 5 cubed. Using that, we rewrite the equation. The term 125 to the power 2 times curly brace x becomes 5 to the power 6 times curly brace x. Step 2. We use substitution. Let y equal 5 to the power 3 times the fractional part of x. Then the equation becomes a quadratic in terms of y. Step 3. Factor the quadratic. We need two numbers that multiply to 125 and add to -30. Those are -5 and -25. So the quadratic factors as left parenthesis y minus 5 right parenthesis times left parenthesis y minus 25 right parenthesis equals 0. Therefore, y equals 5, or y equals 25. Step 4. Consider the case y equals 5. Substituting back, 5 to the power 3 times curly brace x equals 5 to the power 1. When the bases match, the exponents are equal. So 3 times curly brace x equals 1, which gives curly brace x equals 1/3. Because curly brace x equals x minus an integer k, the solutions are x equals 1/3 plus k, where k is any integer. Step 5. Consider the case y equals 25. Since 25 is 5 squared, 1/3 plus k, where k is any integer. Step 5. Consider the case y equals 25. Since 25 is 5 squared, we have 5 to the power 3 times curly brace x equals 5 squared. Therefore, 3 times curly brace x equals 2, so curly brace x equals. In this lesson, we will solve an exponential equation that involves the fractional part of a number. We will follow a clear, step-by-step approach, rewrite the bases, substitute to get a quadratic, solve it, and then use the fact that the fractional part lies between 0 inclusive and 1 exclusive. Here is the problem on screen. Step 1. Rewrite each term using the same base. Since 9 is 3 squared and 3 to the fractional part of x plus 1 is 3 to the first times 3 to the fractional part of x, we can rewrite the equation. First, we write 9 as 3 squared. Next, separate the exponent plus 1 as 3 times 3 to the fractional part of x. Now combine and simplify to get a quadratic form in terms of 3 to the fractional part of x. Step 2. Substitute to transform the equation into a simple quadratic. Let y equal 3 to the fractional part of x. Then the equation becomes y squared minus 6, y plus 5 equals 0. Step 3. Solve the quadratic. It factors as left parenthesis, y minus 5 right parenthesis times left parenthesis, y minus 1 right parenthesis equals 0. So the roots are y equals 5 and y equals 1. Step 4. Apply the key property of the fractional part. The fractional part satisfies 0, less than or equal to the fractional part of x, and strictly less than 1. Exponentiating base 3 preserves order. That means y equals 3 to the fractional part of x lies in the interval from 1 inclusive to 3 exclusive. Therefore, y equal 5 is not allowed because it is outside the interval. The only valid root is y equal 1, which implies 3 to the fractional part of x equals 1, so the fractional part of x equals 0. Finally, the fractional part equals 0 exactly when the number is an integer. Therefore, the complete solution set is x is any integer. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.